मरियम भी नहीं आई, लेकिन बताइए आज भी नहीं आई है मरियम। खैर, चलिए, राइट दी चैप्टर्स नेम इक्विलिब्रियम। Now, in equilibrium, before starting, you should have a small idea about equilibrium, like what is equilibrium. So the previous chapter was thermodynamics. If we go through the sequence of NCERT, the previous chapter was thermodynamics. So in thermodynamics, we are talking about change from A to B. There is some process happening here. And then the system, it reaches a point where there is no change occurring, no apparent change, I would say. No apparent change. Okay. Now, when this no apparent change occurs, we say that it is equilibrium. Right? It is equilibrium. Okay. Achha. I will start the class. Just give me a minute. There are a few relatives who are just leaving right now. I will just say some salam and then I will be back. Okay. Just give me 2 minutes. Thank you, guys. Thank you for waiting. No, let us start. So I was saying that equilibrium is when we don't see any apparent change. Now, in any apparent change in what? Any apparent change in the macroscopic properties. Meaning, there will be no change in temperature, there will be no change in concentration, there will be no change in pressure, or there is no change in volume. All of these are different macroscopic properties. And when a process, we start a process and you leave it for a very long time, and whatever state it achieves after a very long time, we say that is equilibrium. We say that is equilibrium. This meaning of equilibrium, na, that there is no apparent change, you please keep this in your head. आपसे कभी भी कोई इक्विलिब्रियम पूछेगा तो आपको ये आंसर नहीं देना है. But while solving numericals, while reading a question, while even reading some theoretical question, while understanding a concept about equilibrium, you please keep this particular definition in mind where you don't have any apparent change. ठीक है? I will write this down. You also write this down. But it is not the definition of equilibrium. इसको ध्यान रखिएगा. ठीक है? It is not the definition. It is the gist of equilibrium. Equilibrium बताना क्या चाहता है? You write here. Equilibrium is a state when there is no apparent change in the macroscopic property of the system. Now, we have to study two different types of equilibrium. A very small portion is the equilibrium that is related to physical state, that is physical equilibrium. And then we have chemical equilibrium. Okay. So you will have physical equilibrium and you have chemical equilibrium. Okay. Physical equilibrium में first, that is very important that you have to understand, is liquid and vapor. Equilibrium between liquid and vapor. This is very important. Another types of equilibrium can exist between solid and liquid, and you can also have solute, which is solid, and when it is dissolved in solution, you will have solute, which is aqueous. Okay? Now, in chemical equilibrium, there are many things that we will learn. So, chemical equilibrium पर भी आप blank छोड़िएगा. Now, we will understand about liquid and vapor equilibrium using a question from your NCERT. That is the first question of your NCERT. Please write till here. And after that, write the question. They are saying a liquid is in equilibrium with its vapor sealed in a container. आप लोगों ने लिख लिया था? Yes or no? Please tell me, guys. Noha, Harsha, and Alia.
Yes, sir.
Yes, sir.
Now see, a liquid is in equilibrium with its vapor sealed in a container at a fixed temperature. Temperature is fixed. Okay, and it is also sealed inside a container. The volume of container is suddenly increased. Volume kya? It is suddenly increased. Now, what is the initial effect of the change of vapor pressure? How do rate of evaporation and condensation change initially? What happens when equilibrium is restored finally, and what will be the final vapor pressure? Okay, these are certain questions that we're having. Before that, we have to understand what is happening exactly in the equilibrium. While the equilibrium has been established, उस time क्या हो रहा है? ठीक है? So I will take a container. Okay. When you have liquid inside a container, whenever you have liquid inside the container, this liquid will always be evaporating. Make sense? Yes or no? Please tell me, guys. Correct है? Evaporation तो हमेशा होता रहेगा ना. Even if you are going to cover the container, तो आप you take a container, pour some water on it, and cover the container with a lid. Keep it overnight. In the morning, what you will see? No, we are not applying heat. We are not. So it will not evaporate, Harsha, if you don't apply heat. Think about it. You keep a container जिसमें कि पानी है, and it is covered with a lid. Keep it overnight, and when you open the lid, do you see some water droplets on the lid?
Yes, sir.
Where is that water vapor coming? Sorry, where is that water droplet coming from? कोई और पानी तो ऐड हुआ नहीं होगा, right? Whatever water is inside the system, the same water would be evaporating, and as soon as it hit the surface of the lid, it would get condensed and it would be stored as droplet here. That means evaporation always takes place. Now that is why even in winter season, if you are going, I mean, if you have water spread in the floor and you just wipe it, once you wipe it, it is wet. But after some time, that water evaporates and it is dry again. Make sense, Harsha? Yes or no, please tell me.
Yes, sir.
Okay. So evaporation is happening. Evaporation is happening. Also, whenever you have air, normal earth का जो air होता है, this air, it has water vapors in it. Do you know about this? Yes or no?
Yes, sir.
Right. One of the, you can think about it. You have, let us suppose you bought a cold drink, you kept it in the fridge, it got chilled, and as soon as you take it out of the fridge and keep it in the dinner table, the outer surface of the container will be completely wet. Now, obviously, no one has sprayed water on it. Neither the cold drink which was inside it is coming outside. So why are we having that wet surface? That wet surface is only because the water vapors which were around that particular bottle, it hit the surface of the bottle, and that surface of the bottle was very cold. It got condensed, and then we had that liquid water in the surface. So evaporation is also happening. Also, the water vapors which are present inside the container, those water vapor, as soon as they will hit the surface of water, they will be captured by the water molecules, and यहाँ पे condensation भी हो रहा होगा. Makes sense? Yes or no? Please tell me. Both of these things are happening, but they are happening at an equal rate. The amount of water getting evaporated is equal to the amount of water getting condensed. Makes sense? Yes or no? Please tell me.
Yes,
अगर evaporation ज़्यादा होगा, then the water level will go down. If condensation is happening more fastly, then the water level will go up. Make sense? Yes or no? Please tell me, guys.
yes, sir.
This is what is happening at equilibrium. ये तो हम लोग को समझ में आ गया. Rate of evaporation is equal to the rate of condensation. This is happening at what? This is happening at equilibrium. Now we are doing some process. What we are doing? We are increasing the volume of container. तो process हुआ ना? Make sense? Yes or no? Please tell me, guys. हाँ जी.
Yes, sir. Yes, sir.
So the volume was less, and what did we do? We increased the volume. आपने वॉल्यूम को क्या किया? आपने वॉल्यूम को इंक्रीज कर दिया. ठीक है, वॉल्यूम इज इंक्रीज. तो प्रोसेस में क्या हुआ? वॉल्यूम ऑफ कंटेनर is increased. Now, this increase in the volume of container is going to affect the rate of evaporation and rate of condensation both. ठीक है, कंडेंसेशन को समझना थोड़ा सा आसान है पहले. So we'll talk about condensation. ठीक है. Now tell me, initially, when we had smaller volume, then the frequency at which water vapors are hitting the surface of water. ठीक है, there will be some frequency. मान लीजिए 1 सेकंड में 100 molecules of water vapor are hitting the surface. Make sense? When we are initially, जब वॉल्यूम को चेंज नहीं किया तब कितने? How many molecules of water vapor are hitting the surface? What we have assumed? 100. ठीक है, क्योंकि ठीक है 100, we have smaller volume, तो जगह बहुत ज्यादा नहीं है, तो 100. Now if we are going to increase the volume, now the water vapors, they have some other places to go also apart from the surface. So we can say that the frequency will be lowered. Initially, agar 100 molecules of water vapor were hitting the surface, now what will happen? Now less than 100 will be hitting the surface because पहले water vapor के पास कम volume था तो इधर उधर कहीं जाने की जगह नहीं थी. Eventually, it had to hit the water vapors. Now it can go here and there also because we have increased the volume. What will happen? The frequency of water molecules hitting the surface will decrease. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Makes complete sense ना? ठीक है, ध्यान दीजिए. अब तो यहाँ पे हम क्या कह सकते हैं? Rate of condensation, it would decrease. करेक्ट है?
Yes,
सही है?
sir.
Yes, sir.
ठीक है. नाउ एज देखिए, अगर रेट ऑफ कंडेंसेशन डिक्रीज किया है तो वी कैन इस तरह हम कह सकते हैं रेट ऑफ इवेपोरेशन इज गोइंग टू इंक्रीज because now the water vapors they have larger area to go, है ना? इसके पास larger area होगा. And also if you guys remember about entropy is dispersion of energy. When water molecules are in liquid phase, the energy is concentrated. जैसे ही वो vapor में जाएंगे and they will have larger volume to go around. Thinking in terms of entropy, we can say that we are having dispersion of energy. Each water molecule, they will have certain energy, and when it is in liquid phase, it is concentrated. As it goes to the vapor phase, that particular energy of, water molecule, they have energy, and energy is dispersing in the form of water molecules itself. So what will happen? Both the things. The rate of condensation would decrease, and the rate of evaporation would increase. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
ठीक है, ध्यान दीजिए सर. After a point, rate of condensation, it would, what will happen? The rate of condensation would decrease and the rate of evaporation would increase. ठीक है? जब आपने when you, अच्छा, there also what is the initial effect to the change on vapor pressure. ठीक है? अब इस सवाल को देखते हैं हम लोग. Do you know what is vapor pressure? Do you guys know what is vapor pressure?
No, sir.
नहीं, ठीक है. वेपर प्रेशर क्या होता है ना, देखिए, लिक्विड है, लिक्विड इवेपोरेट करेगा, देयर विल बी सम वेपर्स, है ना? बिकॉज ऑफ दिस लिक्विड देयर विल बी वेपर्स on the surface of the liquid, and these vapors would be hitting this wall of the container. When it is hitting the wall of the container, it will be applying pressure on the container. That pressure is known as vapor pressure. Make sense? Yes or no? Please tell me.
Yes.
Yes, sir.
ठीक है, आप ध्यान दीजिए. Let us suppose we have vapor pressure something like this. तो जब rate of evaporation और rate of condensation same है, so certain amount of vapors are present, है ना? कुछ vapor present है and vapor pressure is going to be constant. Now when you increase, as soon as you suddenly increase the volume. Suddenly what did you do? We increase the volume. तो volume की increase करने से you know that PV is equal to nRT. याद है आप लोगों को? हाँ जी, बताएं. ठीक है, तो यहां से आप ये देख सकते हैं प्रेशर इट इज इनवर्सली प्रोपोर्शनल टू एनआरटी अपॉन वी हो जाएगा ना. प्रेशर इट इज इनवर्सली प्रोपोर्शनल टू वॉल्यूम. सो इफ यू आर गोइंग टू इंक्रीज द वॉल्यूम देन व्हाट विल हैपन? देयर विल बी अ डिक्रीज इन वेपर प्रेशर. प्रेशर डिक्रीज करेगा, वेपर प्रेशर इस केस में. सो वेपर प्रेशर इज कांस्टेंट एंड राइट नाउ हियर व्हाट इट हैपन? द ह्यूमन चेंज. ह्यूमन ने कोई प्रोसेस किया, ह्यूमन ने एक चेंज लेके आया. क्या चेंज लेके आया? इट इंक्रीज द वॉल्यूम. देन सिस्टम में क्या हुआ? द वेपर प्रेशर डिक्रीज्ड. ठीक है, यहां पे सिस्टम. अब उसके बाद एज सुन एज द वेपर प्रेशर डिक्रीज्ड, वेपर प्रेशर डिक्रीज हो गया, और जब वॉल्यूम ज्यादा मिला तो फिर सिस्टम ने क्या किया? सिस्टम डिक्रीज द रेट ऑफ कंडेंसेशन एंड इट इंक्रीज द रेट ऑफ इवेपोरेशन. when it decrease the rate of condensation and it increase the rate of evaporation, more water vapor are formed. है ना? इवेपोरेशन का रेट बढ़ रहा है, कंडेंसेशन का घट रहा है, तो वाटर वेपर ज्यादा फॉर्म होंगे. मेक सेंस? यस और नो? प्लीज टेल मी.
Yes, sir.
नाउ दिस चेंज इज डन बाय, यहां से यहां पे अबाउट, जब मोर वाटर वेपर्स आर फॉर्म, जब नंबर ऑफ मोल्स बढ़ेगा तो प्रेशर भी क्या होगा? बढ़ेगा, बिकॉज प्रेशर इज you can see that pressure is directly proportional to number of moles. If we are having more number of moles of water, so then the pressure is also going to increase. So there will be increase in pressure. और फिर से ये वेपर प्रेशर तक जो इनिशियल था कांस्टेंट वहां तक आगे अगेन इट विल अचीव इक्विलिब्रियम. सो यहां से यहां तक ह्यूमन ने एक चेंज किया, उसके अगेंस्ट सिस्टम एक चेंज करता है. ठीक है. सो दिस इज हैपनिंग. ऑल ऑफ यू अंडरस्टूड? यस और नो? प्लीज टेल मी व्हाट इज द इनिशियल इफेक्ट on initial effect of the change on vapor pressure. Say vapor pressure
Sir,
decreased.
it will reach the initial value.
हाँ, तभी तो रेट ऑफ, फिर से तो क्या होगा ना, जब when you will have the same vapor pressure, then again the rate of evaporation and rate of condensation will be equal once again. तो तब तक the rate of condensation decrease होता रहेगा, rate of evaporation increase करता रहेगा. ठीक है. And they will meet at a point जहां पे फिर से क्या होगा, they are again equal.
Okay.
And then the vapor pressure will get the same value. देखिए यहाँ पे जरा, प्रेशर इट इज इक्वल टू नंबर ऑफ मोल्स आर पी अपॉन वी. वॉल्यूम बढ़ गया. ठीक है. तो हम लोगों ने क्या किया, नंबर ऑफ मोल्स भी बढ़ा दिया, तो प्रेशर वापस से वही आ जाएगा ना. मेक सेंस?
Yes, sir.
ठीक है. न्यूमरेटर डिनोमिनेटर दोनों से सेम चेंज. हाउ डू रेट ऑफ इवेपोरेशन एंड कंडेंसेशन चेंज इनिशियली? तो रेट ऑफ कंडेंसेशन इज गोइंग टू डिक्रीज, rate of evaporation is going to increase. What happens when equilibrium is restored and what will be the final vapor pressure? Final vapor pressure will be same as initial. ठीक है. You can write it down. Raise your hand once you're done writing. Waiting for Noha and Harsha. Just waiting for Noha now. Okay. Everyone is done. This is between liquid and vapors. Okay. Now, a similar type of equilibrium, it is also established when we are dissolving a solute in solvent. So, you write here equilibrium while dissolution. So solute, it is in solid state. It dissolves inside the water and it becomes solute in aqueous state. Okay, so this process is known as dissolution. And this is known as crystallization. When solute in the aqueous form, it is reformed as solid solute, crystallization. Okay. Now, initially when you add the solute in a large amount of water, let us say, then the rate of dissolution is greater than rate of crystallization. Okay. Now, after that, what happens when it is dissolved completely? Okay. When it is dissolved completely, then what will happen? The rate of dissolution and the rate of crystallization will again become equal. ठीक है, तो तभी क्या होगा ना, that is why you will not see any salt molecules inside the solution, even though crystallization is also happening. Let us suppose 10 millimole is crystallizing per second, ठीक है, and 10 millimole is also dissolving per second. तो दोनों तो बराबर है, like 10 millimoles is getting crystallized and 10 millimole is getting dissolved also. So obviously you are not going to see any salt particles inside water molecule, water container. ठीक है, अब समझिए जरा. Let us suppose, ठीक है, this is again all of the times the rate is going to be equal when you achieve the equilibrium. जब process हो रहा होता है ना, this is time when the process is happening. Also, let us suppose if you add too much salt, ठीक है, if you add too much salt, then what you will see that there is some salt inside the container. ठीक है, so when you see some salt inside the container, it is not that the rate of crystallization is greater than rate of dissolution. उस टाइम भी क्या हो रहा है ना, even though you have the salt up here, we have achieved equilibrium. Now you see there is no salt getting dissolved. Here still you will have rate of crystallization is, let us suppose, 1 millimole per second, and rate of dissolution is going to be 1 millimole per second. But since we have achieved an equilibrium where the salt is still there, और salt इसके आगे और dissolve नहीं हो रहा है, so we have achieved an equilibrium where the salt is not dissolved, and we can also achieve an equilibrium where the salt is dissolved. So it depends on how much amount of salt you have put. So we will get different states of equilibrium. Equilibrium का कोई एक state नहीं होता. It depends on the initial condition. हमने start कैसे किया था, ठीक है? That is why you will just remember that when the equilibrium is established, then rate of dissolution is equal to rate of crystallization. Right now you cannot say that whether we are having salt, undissolved salt inside the container, or we are having completely dissolved, because we don't know the initial conditions. Until unless we know the initial condition, we cannot say that how the equilibrium looks like. But the condition for equilibrium is that the rate of dissolution is equal to rate of crystallization in the case of when we are dissolving something. In the case of evaporation and condensation, rate of evaporation is equal to rate of condensation. So basically आपका rate of forward is equal to rate of backward reactions. इस तरह से रहता है, ठीक है? Now these are the physical equilibriums. के बारे में इतना ही जानना था बस आपको, that rates are equal. After this we will talk about chemical equilibrium. Now before going to chemical equilibrium, this type of reactions are not generally, what I can say, they are not generally found. ऐसे देखने में आपको नहीं लगेगा, because we have just learned in thermodynamics कि you start with reactant and you end with product. Fine. Now, if the reactant is having higher energy and product is having lower energy, then it is going to be exothermic. That means you can easily go from reactant to product in a spontaneous way. But each and every reaction is reversible to a certain extent. And this was initially found when Napoleon, ये कहां से आ गया आप लोगों को लगा होगा ना, when Napoleon, he visited natron lakes. ठीक है, natron lakes are near Egypt, and natron lakes, it has sodium chloride and calcium carbonate. Okay? And he saw that in the banks of natron lake, he saw it had sodium carbonate and calcium chloride. Okay? Calcium chloride. Now, he saw these two molecules. Please remember what he saw. He saw these two molecules in the bank of natron lake. Once again, I'm saying he saw sodium carbonate and calcium chloride in the banks of natron lake. उसने ये दोनों molecules को देखा. And there is a reaction that he knew because he had done a reaction in the lab. उसने क्या reaction किया हुआ था? In the lab, he had done the reaction that when you combine Na2CO3 and calcium carbonate, sorry, sodium carbonate and calcium chloride, you will get sodium chloride and calcium carbonate. Then it struck, please थोड़ा सा ध्यान दीजिएगा यहाँ पे. This is he saw where in the natron lakes, नॉट नेपोलियन. नेपोलियन के साथ ना साइंटिस्ट रहते हैं. जैसे इंडिया है तो इंडिया के थिंक टैंक होता है ना, नीति आयोग जैसे इंडिया का थिंक टैंक है, राइट. तो उसी तरह से जो भी एम्परर्स होते हैं उनका कुछ ना कुछ मिनिस्ट्री होता है. मिनिस्ट्री में अलग अलग लोग रहते हैं. जैसे अकबर के बारे में आपने सुना होगा कि नौरत्न थे उसके. तो हर एक फील्ड का जो एक्सपर्ट रहता है वो रहता है सारे एम्परर के साथ. सो नेपोलियन ही हैड अ केमिस्ट विथ हिम. ठीक है. एंड द केमिस्ट ही ऑब्जर्व दैट ही सॉ सोडियम कार्बोनेट एंड कैल्शियम क्लोराइड. और उसने लेकिन एक रिएक्शन देखा हुआ था कि जब सोडियम कार्बोनेट और कैल्शियम क्लोराइड को अगर आप ट्रीट करेंगे, एक दूसरे के सामने लेके आएंगे, इट वुड गिव यू NaCl and CaCO3. देन ही स्टार्टेड वंडरिंग कि इन द लेक, द बैंक्स ऑफ लेक, it had the required starting materials, sodium carbonate and calcium chloride, but it is not giving this reaction, sodium chloride and calcium carbonate ka. When these two things are present, it should react with each other and it should give NaCl and CaCO3, but it was not given. Now from here, the concept of reversible reaction was introduced, that if we have A and B, and A and B, it gives C and D, then C and D, when combined in appropriate amount, it will also give you A and B. It would also give you A and B. Okay. So this is the concept of reversible reaction. It was introduced because the field of equilibrium, it started only because Napoleon, he visited Natron Lake. है ना? इसके, I mean, right now we have this particular history. अगर ये Natron Lake नहीं जाता तो कोई और history होती है हमारे पास. Eventually you had to study equilibrium, है ना? उससे कुछ ये नहीं है. आप लोग नेपोलियन को ऐसे गाली मत देने लग जाइएगा कि क्यों गया आप, है ना, Natron Lake गए, वहां पे क्यों देखा उसके साइंटिस्ट ने. So anyhow you had to study equilibrium. This is through the route of Napoleon and Natron lakes, but we got to know the idea of reversible reaction. Now, what is reversible reaction? Isko zara likhiye. This is important. The concept of reversible reaction. Reversible reaction. अगर आपको
chemical equilibrium, right?
Sorry, yes,
So this
Sarja.
is under chemical equilibrium, right?
Now we are moving towards chemical equilibrium. ठीक है. अब थोड़ा अगर आप लोग ना क्लास 10th के इसमें जाइएगा, क्लास 10th के केमिस्ट्री के इसमें, तो आप लोग फिजिकल चेंज, केमिकल चेंज पढ़ते हैं, राइट? करेक्ट? ये दोनों पढ़ते हैं कि नहीं पढ़ते? पढ़ते हैं ना, फिजिकल चेंज, केमिकल चेंज.
Yes,
एंड जनरली इन केमिकल चेंज आप व्हाट डू यू गाइस स्टडी? यू स्टडी दैट इट कैन नॉट बी रिवर्स्ड, राइट?
Yes, sir.
ठीक है. तो उसके बारे में थोड़ा सा हम आप लोगों को बता देते हैं. दैट इज फॉर श्योर वंस द प्रोसेस हैज टेकन प्लेस, जो ये प्रोसेस हो रहा है ना, दिस प्रोसेस कैन नॉट बी रिवर्स्ड. ठीक है. प्रोसेस जब कंप्लीट हो जाए, ए से बी बन जाए, ठीक है, देन आई एम नॉट सेइंग दैट दिस पर्टिकुलर मटेरियल्स, बट बी कैन बी कन्वर्टेड टू ए अंडर सर्टेन कंडीशंस. दोस कंडीशंस में बी वेरी एक्सपेंसिव, बट इट कैन बी कन्वर्टेड. ठीक है. तो पहले आप रिवर्सिबल रिएक्शन लीजिए. Again, there are certain reactions which are not reasonably, that they cannot be reasonably called reversible reaction because they are extremely expensive and not feasible. I mean, right now it is not feasible, but most of the reactions you can say that they can be reversed. They are reversible reaction under certain conditions. चलिए यहाँ पे लिखिएगा the reaction. What is reversible reaction? The reaction in which products that are formed can also react with each other to form reactants under suitable condition. Under suitable condition. ठीक है, तो let us talk about a reaction which is reversible in nature, and we are starting with A से B बन रहा है और B से वापस A भी बन सकता है. ठीक है, now there will be certain speed at which A is getting converted to B. तो इसको हम लोग बोलेंगे rate of forward reaction, and the speed at which B is getting converted to A, इसको हम लोग बोलेंगे rate of backward reaction. ठीक है, rate of backward reaction. Now our reactant is A, so we started with A only. Initially what would happen when only A is present? When only A is present, what I can say, सिर्फ A से B बन रहा होगा ना, because B तो है ही नहीं अभी. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
ठीक है, so at least what I can say is rate of forward reaction will be greater than rate of backward reaction initially when only A is present. Make sense? Yes or no?
Yes, sir.
ठीक है, now as B is getting formed, जैसे जैसे B बन रहा है, when only is rate of forward reaction is B is greater than rate of backward reaction, then what will happen? B is getting formed, and since B is also able to convert to A, what I can say is कि अभी B जो बनना स्टार्ट हुआ है, इसमें हम कम से कम ये कह सकते हैं that rate of backward reaction will start to increase. जीरो से वो कुछ बढ़ने लगेगा. Make sense? Yes or no? Please tell me.
Yes, sir.
ठीक है, ध्यान दीजिएगा, जरा ध्यान दीजिएगा, बहुत बहुत ध्यान देने की जरूरत है यहाँ पे. मान लेते हैं द रेट ऑफ फॉरवर्ड रिएक्शन, इसमें पेन यार, जस्ट अ सेकेंड. ओके, सो लेट अस सपोज 100 मोल, 100 तो बहुत ज्यादा हो जाएगा ना, लेट अस सपोज 0.2 मोल पर सेकेंड was the initial rate of forward reaction. ठीक है, इनिशियली इतना था. रेट ऑफ बैकवर्ड रिएक्शन तो जीरो, तो स्टार्ट हुआ होगा 0.01, ठीक है, 0.02, धीरे धीरे बढ़ेगा ना, इट इज गोइंग टू इंक्रीज ना. द रेट ऑफ बैकवर्ड रिएक्शन इट इज गोइंग टू स्लोली इंक्रीज. जैसे जैसे बी की कंसंट्रेशन बढ़ेगी, मोर बी इज अवेलेबल, जितना ज्यादा बी अवेलेबल होता जाएगा उतना ज्यादा स्पीड में रेट ऑफ बैकवर्ड रिएक्शन होता रहेगा. 0.2, 0.003, ठीक है, धीरे धीरे बढ़ता रहेगा. एंड सिंस what is happening, rate of forward reaction 0.2 mole per second, और A की concentration अब धीरे धीरे घट रही है ना, that is also happening. Make sense? Yes or no? Please tell me.
Yes, sir.
So we will say that concentration of A is decreasing, and therefore rate of forward reaction will also decrease. तो rate of forward reaction जब 0.2 था, फिर थोड़ी देर बाद अगर देखेंगे, because a concentration of A has been lowered, 0.019 हो जाएगा, 0.19 my bad, 0.19 and so on. There will be a time, let us suppose at 0.1 mole per second, इस टाइम क्या होता है, दोनों रेट ऑफ फॉरवर्ड रिएक्शन एंड रेट ऑफ बैकवर्ड रिएक्शन क्या हो जाता है, 0.1 मोल पर सेकेंड. मेक सेंस? यस और नो? प्लीज टेल मी. हो सकता है ऐसा? क्या ख्याल है?
Yes, sir.
है ना, ऐसे ही होगा. धीरे धीरे रेट ऑफ फॉरवर्ड रिएक्शन बढ़ रहा है, रेट ऑफ सॉरी फॉरवर्ड रिएक्शन घट रहा है, बैकवर्ड रिएक्शन बढ़ रहा है, सो दे विल मीट एट अ पॉइंट. अब बताओ, इस टाइम पे जब रेट ऑफ फॉरवर्ड रिएक्शन इज इक्वल टू रेट ऑफ बैकवर्ड रिएक्शन हो जाएगा, तो अगर एक मोल ए से बी बना तो एक मोल बी से ए भी बन जाएगा. मेक सेंस? ठीक है, ध्यान दीजिएगा जरा, इस बात को ध्यान दीजिएगा। वी स्टार्टेड विथ रेट ऑफ फॉरवर्ड रिएक्शन और बी बना। एज सुन एज रेट ऑफ फॉरवर्ड रिएक्शन एंड रेट ऑफ बैकवर्ड रिएक्शन इज इक्वल, उस टाइम एक चीज मान लेते हैं, बी की कंसंट्रेशन हो गई, लेट अस सपोज 0.2 से कुछ कुछ होते होते ये हो गया 2 मोल, ठीक है, और ए की कंसंट्रेशन जो थी ये मान लीजिए हो गई 1 मोल, ठीक है। ए का हमने स्टार्ट किया था, किसी स्टार्टिंग में कुछ था ए का कंसंट्रेशन, वो धीरे धीरे घट के 1 मोल पहुंच गया। बी का कंसंट्रेशन 0 था, वो बढ़ बढ़ के कहां पहुंच गया, 2 मोल पहुंच गया। And right now we have achieved this equilibrium, that rate of forward reaction is equal to rate of backward reaction. Now, in 1 second, what would happen? A will get convert to B. कितना? 1 second में 0.1 mole will 0.1 mole of A is going to get convert to B. In the same second, what would happen? B का 0.1 मोल किस में कन्वर्ट हो जाएगा? A में। मेक सेंस है सुनो? ऐसा ही होगा when the
Yes.
rate of forward and rate of backward reaction is achieved, ठीक है। समझिए, when A is getting converted to B, तो A का कंसेंट्रेशन घटना चाहिए 0.1 मोल, बट इन द सेम सेकंड B से 0.1 मोल A में कन्वर्ट हो गया, तो A का कंसेंट्रेशन बढ़ जाएगा कितना? 0.1 मोल। एविडेंटली व्हाट वुड हैपन, A का कंसेंट्रेशन 1 मोल से ना आगे बढ़ेगा ना पीछे घटेगा। सिमिलर थिंग विल हैपन सिंस A is getting converted to B, B का कंसेंट्रेशन बढ़ जाना चाहिए था 0.1 मोल से, but in the same second B's concentration is going to decrease because B is getting converted to A by 0.1 mole, ये घट जाएगा। So evidently what is going to happen, B की भी concentration क्या हो जाएगी? It is going to be a constant, that is 2 mole. Now when the equilibrium has been achieved, we cannot really see the rate of forward and rate of backward reaction, but what we can measure is that concentration becomes constant. It is not equal, it becomes constant. Make sense, yes or no? Please tell me, guys.
Yes, sir.
ठीक है, किसी को कोई दिक्कत यहां तक?
No, sir.
ठीक है, प्लीज कॉपी दिस डाउन। थोड़ी थोड़ी चीजें, कुछ भी आप उसको लिख लीजिए। रेज योर हैंड वंस यू डन। ठीक है, चलिए अब लिखने की बारी है। प्लीज राइट दीज थिंग्स विथ मी। एट इक्विलिब्रियम, at equilibrium, rate of forward reaction is equal to rate of backward reaction, ठीक है। Also the concentration of reactant and product becomes constant। It does not mean that they are equal. ठीक है, कांस्टेंट का मतलब इक्वल नहीं है. रिएक्टेंट इज इक्वल टू प्रोडक्ट नहीं है. रिएक्टेंट का कांस्टेंट हो चुका है विद रिस्पेक्ट टू टाइम एंड प्रोडक्ट का भी कंसंट्रेशन कांस्टेंट हो चुका है. राइट अ क्वेश्चन. Choose the correct options. ठीक है, ऑप्शन और ऑप्शंस. रेट ऑफ फॉरवर्ड. अच्छा, ऑप्शन एट इक्विलिब्रियम ना. एट इक्विलिब्रियम क्या हो रहा है? रेट ऑफ फॉरवर्ड इज इक्वल टू रेट ऑफ बैकवर्ड. Concentration of reactant is equal to concentration of product. Concentration of reactant and product are constant. Tell me which of the options are correct in the chat. Yeah, very good. Only A and C is correct. ठीक है, A is correct and C is correct. Reactant and product, it is not correct. ठीक है, not necessarily. Right, next. Choose the correct option. Another question. Yes, no. Another question. ये ग्राफ्स हैं तो थोड़ा सा हम आप लोग को समझा देंगे. ठीक है, these are graphs. Here you have rate. ठीक है, so rate of backward reaction बढ़ता है. This is rate of backward reaction. And rate of forward reaction पहले कुछ होगा, उसके बाद rate of घट जाएगा. Rate of forward reaction. ठीक है, and we say that at this point equilibrium is established. यहाँ पे आ गया equilibrium. ठीक है, this is just time. With respect to time we have this. Now we have another plot. This is the rate of backward reaction and this is the rate of forward reaction. ठीक है, and we are saying at this point equilibrium has been established. ठीक है, this is again rate and this is time. This is A, this is B. Let's see one more. अभी दो तीन और आएंगे. Now we have concentration here. ठीक है, concentration is saying that at this point equilibrium has been established. ठीक है, this is time. So option number C. Again here we have concentration. Here we have time. This is option D. And at this point ठीक है, we are saying at this point equilibrium has been established. The same graph. This is option number E. And this time we are just saying that equilibrium has been established here. ठीक है। And then let us suppose you have something like this. Time, concentration. ठीक है। अच्छा, दिस इज प्रोडक्ट एंड दिस इज रिएक्टेंट। ठीक है, ये हम नहीं लिख रहे थे। प्रोडक्ट की कंसंट्रेशन बढ़ रही है, रिएक्टेंट की कंसंट्रेशन घट रही है। प्रोडक्ट की कंसंट्रेशन बढ़ रही है, रिएक्टेंट की कंसंट्रेशन घट रही है। ठीक है, एंड यू आर सेइंग दैट दिस पॉइंट वी हैव इक्विलिब्रियम। ठीक है, ध्यान से देखते हैं अब एक एक को। एट दिस पर्टिकुलर पॉइंट, ठीक है, जो रेट ऑफ फॉरवर्ड रिएक्शन है और रेट ऑफ बैकवर्ड रिएक्शन बोथ आर सेम। मेक सेंस? यस और नो? प्लीज टेल मी गाइस। सही है?
Yes, sir.
ठीक है, तो तो हम ये कह सकते हैं, राइट, रेट ऑफ फॉरवर्ड रिएक्शन, रेट ऑफ बैकवर्ड रिएक्शन, सिंस दे आर इक्वल, सो या दिस ग्राफ इज correct. Make sense, all of you? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Now, in the second case, the rate of forward reaction is somewhere here, and rate of backward reaction is somewhere here. So obviously, these two are different. Rate of forward reaction and rate of backward reaction are different, na? When we are saying that equilibrium has been established.
Yes, sir.
So we will say that no, this graph is not correct. Equilibrium जब establish होगा तभी establish होगा when the rate of forward and backward reactions are equal. Right now, the rate of forward reaction is a constant and rate of backward reaction भी constant हो चुका. They are not equal. They should be equal. Make sense? Yes or no?
Yes, sir.
Yes,
ठीक है,
sir.
ध्यान से देखिए। नेक्स्ट पॉइंट यहाँ पे, अगर हम रिएक्टेंट की कंसंट्रेशन देखें तो रिएक्टेंट कंसंट्रेशन इज नाउ कांस्टेंट, इट इज नॉट चेंजिंग विद टाइम। प्रोडक्ट की कंसंट्रेशन भी इट इज नॉट चेंजिंग विद टाइम, राइट? सो इक्विलिब्रियम का कंडीशन आ चुका है दैट एट इक्विलिब्रियम व्हाट हैपेंस, द reactant concentration and product concentration becomes constant. So we'll say, yeah, true, this is correct. Make sense? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
अब यहाँ पे देखते हैं in the next graph. If I go move from here, this is the concentration of reactant. It is still going to decrease, right? At this point, it is still decreasing, and and the concentration of product is still increasing. Since the concentration of reactant and product are not constant, you will see that it is not equilibrium. Make sense? Yes or no? Please tell me.
Yes,
Yes.
sir.
Now, in the next plot, if you see the concentration of product, it is now constant. The concentration of reactant, it is also a constant. So we will say that this graph is correctly depicting equilibrium. And in this case, this is the F case. Okay. In F case, you can also see that this is reactant, this is product. The concentration of reactant is also achieved at equilibrium value. Equilibrium nahi, a constant value, and the concentration of product has also achieved a constant value. In this particular case, the concentration of reactant and product are also equal, but equal has nothing to do with equilibrium. Make sense? कंसंट्रेशन का इक्वल होना इक्विलिब्रियम नहीं है, कंसंट्रेशन का कांस्टेंट होना इक्विलिब्रियम है, एंड दैट इज ओनली इनफ। या दिस इज करेक्ट, ये इक्विलिब्रियम है, but it is not because the concentration of reactant and product are equal. Rather, it is because the concentration of reactant and product, they have achieved a constant value. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
कॉपी कीजिए। Waiting for Noha and Harsha. Just waiting for Noha. Okay, fine. Noha is also done. Okay. Now, since the concentration at equilibrium does not change, and we define equilibrium as the state or the state of system in which the rate of forward reaction is equal to rate of backward reaction, we have something called equilibrium constant. Okay, please write equilibrium constant. Equilibrium constant. Okay, so if we have a reaction, a general reaction A is the stoichiometry, and the lower case a, small a is the stoichiometry, that is number 1 2 3 4 kuch hoga. Capital A is the chemical species. We have AA plus BB gives CC plus DD. Then we define the equilibrium constant as the concentration of product raised to their stoichiometric coefficient divided by the concentration of reactant raised to their stoichiometric coefficient. This is Kc, that is equilibrium constant in terms of concentration. Okay, in terms of concentration. Now, if all the species are gas, then we define Kp, equilibrium constant with respect to pressure, because गैस का कंसंट्रेशन जानना बड़ा मुश्किल है, गैस का प्रेशर जान सकते हैं. ठीक है, इट इज वेरी इजी टू पुट अप अ बैरोमीटर और मैनोमीटर, वो प्रेशर आपको बता देगा. सो इट विल बी इक्वल टू द प्रेशर ऑफ C to the power C, which is the stoichiometric coefficient, multiplied by the pressure of D to the power D divided by the pressure of A to the power A and the pressure of B to the power B. Write this down. तो यहाँ पे देखिए, where concentration of A, concentration of B, concentration of C and concentration of D are the equilibrium concentration. ना ही इनिशियल ना ही बीच का, फाइनली when the complete process is over, तब जो concentration होगा ना, when no apparent change is happening, अब A की concentration change ही नहीं हो रही है, that concentration. And here also, where pressure of A, comma pressure of B, pressure of C and pressure of D are the pressure of A, comma B, comma C and D at equilibrium. Raise your hand once you're done. Next, relationship between ये C and KP. ठीक है. Now we know that PV is equal to nRT, ideal gas equation. P will be equal to N upon P RT, number of moles of gas per liter of number of moles of gas per liter is what? It is concentration. No? So P is equal to, इसको क्या लिख सकते हैं, concentration into RT. Now I can say that pressure of A, it is equal to CART. ठीक है, CART. बस अब ध्यान दीजिएगा यहाँ पे. We know that Kp is equal to pressure of C to the power C divided by pressure of D to the power D divided by pressure of A to the power A and pressure of B to the power B. I will plug in this value of PA, PB and PCPD. So PC के लिए क्या लिख सकते हैं, concentration of CRT to the power C. Then I can write concentration of D. Concentration of D लिख रहा हूँ ना, CD इस तरह से. DRT to the power D divided by concentration of ART to the power A and concentration of BRT to the power B. Now RT to the power C, D, B, A सबको अलग कर देते हैं. We will have concentration of C to the power C, concentration of D to the power D divided by concentration of A to the power A and concentration of B to the power B multiplied by RT is common, ऊपर भी नीचे भी. ठीक है. RT के लिए हम यहाँ पे क्या लिख सकते हैं, ऊपर में होल टू दी पावर C प्लस D. बेसेस आर सेम, पावर्स आर डिफरेंट. बेस को कॉमन लिया, पावर को ऐड किया, डिवाइड बाई RT टू दी पावर A प्लस B. नाउ I can write Kp, it is equal to C की power C, D की power D, A की power A and B की power D. This is actually concentration of C to the power C, concentration of D to the power D, concentration of A to the power A and concentration of B to the power B. This is nothing but equilibrium constant with respect to concentration. Now here also you can see RT, the base is common and the powers are different. So I can write RT to the power, just give me a second, RT to the power C plus D minus A plus B. ठीक है. Now Kp is defined only when you have gases. इसको हम क्या लिख सकते हैं, Kc into RT to the power number of moles of gas in what? Number of moles of gas in product. Product में C plus D minus number of moles of gas in reactant. इसी को और क्या लिख सकते हैं आप, Kp is equal to Kc to the power RT to the power delta Ng, number of moles of gas का difference, the reactant and product. इसको प्लीज लिख लीजिए एक बार, लिखते लिखते समझ में आएगा आपको ना, बट प्लीज थोड़ा माइंड ऑन करके लिखें. लेट मी नो इफ यू हैव डाउट एनीवेयर. Just waiting for Naha now. Okay, see. What is delta Ng? Delta Ng, it is equal to number of moles of gas in product minus number of moles of gas in the reactant. ठीक है, ध्यान दीजिए. अब डेल्टा Ng के कुछ सर्टेन केसेस हो सकते हैं. डेल्टा Ng कैन बी ग्रेटर देन 0. डेल्टा Ng कैन बी ग्रेटर देन 0. तो इसका मतलब क्या होगा बताइए. प्रोडक्ट हैज dash moles of gas more या less. बताओ भाई.
More.
more, करेक्ट. एक और केस हो सकता है इसमें डेल्टा Ng इज इक्वल टू 0. अच्छा, व्हेन द प्रोडक्ट, जब यहाँ पे डेल्टा Ng इज ग्रेटर देन 0, दैट मींस RT टू द पावर समथिंग, R2 टू द पावर समथिंग इनटू Kc, तो दिस होल वैल्यू विल बी मोर ना, क्योंकि डेल्टा Ng क्या 0 से ज्यादा है. 0 से ज्यादा होगा तो 0.11 नहीं होगा, इट विल बी 1 2 इस तरह से ना, बिकॉज नंबर्स माइनस होंगे ना. नंबर ऑफ मोल्स ऑफ गैस तो 5 - 2 ऐसे कुछ नंबर आएगा. So this whole thing will be more. So I can say that when delta Ng is greater than 0, in that case, Kp is greater than Kc. ठीक है. When delta Ng is equal to 0, then number of moles of gas is equal to, ऐसे लिख सकते हैं, product has same moles of gas. ठीक है. तो जब डेल्टा Ng 0 हो जाएगा, तो RT to the power 0 हो जाएगा, and anything to the power 0 it is equal to 1, and anything multiplied to Kc will be Kc. So Kc and Kp in that case will be equal. Kp will be equal to Kc, and one case could be in which delta Ng is less than 0. यहाँ पे product has less moles of gas हो जाएगा, and in this case Kp will be smaller than Kc. ठीक है. बस एक और पॉइंट लिख लीजिए. इन Kp is equal to Kc, RT to the power delta Ng, इसमें R की वैल्यू क्या क्या हो सकती है. R की वैल्यू आप लीजिएगा 0.0821 लीटर ATM पर केल्विन पर मोल, व्हेन, जब प्रेशर इज इन ATM अगर प्रेशर दे तो आप लीजिएगा 0.021, and if it is given in bar then you will take 0.0831 liter bar per Kelvin per mole, and pressure is in bar. ठीक है.
Sir, in the textbook it's given 8.31.
That is for joules. देखिए यूनिट 8.314 ना,
Yes, sir.
वो जूल्स के लिए होगा. वो थर्मोडायनेमिक्स में ना हम लोग एनर्जी की बात कर रहे होते हैं. सो इन दैट केस it will not be liter ATM per Kelvin per mole, it will be joules per Kelvin per mole. देखिए, is your textbook with you right now?
No, sir.
अच्छा, आप याद से बोल रहे हैं. नहीं नहीं, ठीक कह रहे हैं, नो प्रॉब्लम. जब हम लोग एनर्जी से डील करते हैं ना, व्हेन यू हैव टू यूज दिस आर इन टर्म्स ऑफ एनर्जी, तो फिर हम लोग वहां पे 8.314 लेते हैं.
ओके सर।
या 8.3 लेते हैं, ठीक है। ये याद है आपको, लीटर एटीएम इज इक्वल टू 100 जूल।
नो सर।
नहीं याद है, भूल गए? अच्छा, थर्मोडायनेमिक्स जाके देखिएगा ना, तो थर्मोडायनेमिक्स में आपको मिलेगा लीटर एटीएम इट इज इक्वल अप्रोक्सीमेटली इक्वल टू 100 जूल्स। तो वही देखिए आप, इसी वजह से ना 2 डेसिमल पॉइंट का बस फर्क है। व्हेन वी आर गोइंग फ्रॉम लीटर एटीएम या लीटर बार से जूल्स में जा रहे हैं आप, सो व्हेन यू मल्टीप्लाई 100 टू दिस टू ना, तो वो अप्रोक्सीमेटली वही वैल्यू हो जाएगा। तो जस्ट द कन्वर्जन ऑफ यूनिट्स, नथिंग एल्स।
ओके।
Right, everyone, and tomorrow we will learn about the applications of equilibrium constant. मेन थिंग्स जो आपको लेके जाना है आज की क्लास से, वो क्या क्या है? Rate of forward reaction is equal to rate of backward reaction in equilibrium. Concentration of reactant and product, it becomes constant. And equilibrium is a dynamic process. फॉरवर्ड रिएक्शन भी होता रहता है, बैकवर्ड रिएक्शन भी होता रहता है, रिएक्शन बंद नहीं होता, ठीक है। रिएक्शन इज नॉट स्टॉपिंग। रिएक्शन की वजह से जो चेंज आना था वो नहीं हो रहा था, बिकॉज इट इज कैंसल्ड फॉरवर्ड और बैकवर्ड में सेम रेट की वजह से, ठीक है। जस्ट वेटिंग फॉर नोहा एंड हर्षा। चलिए।